Hello everybody and once again welcome to Pankaj's Echelon tutorials. In this today's session we are going to do some revision in chemistry because IGCSE uh, exams are under the nose, and here in this today's session I am going to deal with this one single question on stoichiometry, and the question is right on the screen in front of you. It says that 76.18 gram of elemental sulfur reacts with 18.98 grams of elemental oxygen to produce sulfur trioxide. What is the limiting reagent? So he has asked you the question, what is the limiting reagent? What is the amount of sulfur trioxide formed in grams? So he has asked you to find out sulfur trioxide in grams. And further the question says if 30.21 grams of sulfur trioxide was formed in the laboratory, then what is the percentage yield of sulfur trioxide? So this is the third question that he has asked you. What is the percentage yield of sulfur trioxide? Okay. So these are the three questions you have to answer, and the reaction is between 76.18 gram of elemental sulfur and 18.98 gram of elemental oxygen. So let us get started with the solution. The very first step is writing a chemical equation, a balanced chemical equation. So I'll start with sulfur, elemental sulfur plus oxygen, giving you SO3, sulfur trioxide. Now to balance this equation, I'll put a 3 over here and 2 over here and 2 over here, right? Now this is a balanced chemical reaction. Second step is I'll have to write down what are the stoichiometric ratios. Stoichiometric ratios. Okay. Now the stoichiometric ratios corresponding to sulfur, oxygen, and SO3 are nothing but the coefficients that you see in front of this reactants and the products. Okay, these are the stoichiometric ratios. So for sulfur, the stoichiometric ratio is 2, for oxygen it is 3, and for SO3 it is again 2, right? Next is, now let us try to find out which is the limiting reagent. Either S will be the limiting reagent or O2 will be the limiting reagent. We'll have to check it, which one is the limiting reagent. So let us find out something called limiting reagent constant, okay, denoted by a K, for both sulfur and oxygen. Let us try to find out for sulfur first. Okay, so limiting reagent constant K for sulfur is given by this formula: moles of sulfur divided by stoichiometric ratio of sulfur. Okay, unfortunately we don't know the moles of sulfur because the sulfur is given to us in grams. Okay, so this sulfur which is given to us in grams, that is 76.18 gram, if you divide this by the AR, that is the RAM of sulfur, then we will get the answer for the number of moles of sulfur, right? So N of sulfur, that is the number of moles of sulfur, will be equal to 76.18 upon AR of sulfur, and this AR of sulfur happens to be 32, right? So 76.18 divided by 32, let us work out how much it comes to. 76.18 divided by 32, I'm getting the answer as 2.381. 2.381. Okay, this is my number of moles. Now this I'm going to substitute here in this formula. Number of moles of sulfur will be 2.381 upon, what is the stoichiometric ratio of sulfur? I have mentioned here stoichiometric ratio of sulfur is 2. So this will give me the answer for the K value of sulfur. So 2.381 divided by 2 works out to 1.190. 1.190. Now this is the K value for sulfur. Okay, let me do one more thing. Let us find out the K value, that is limiting reagent constant K for oxygen. Same procedure. This will be number of moles of oxygen divided by stoichiometric ratio of oxygen. Now number of moles of oxygen N will be given by the grams of oxygen that is used is 18.98. Okay, so I'll write 18.98 upon, now what is the MR of uh, oxygen? It is 32. So 18.98 upon 32, right? And this should give me the answer as 18.98 divided by 32 works out to 0.593. Works out to 0.593. So this is the number of moles of oxygen that I will plug in this formula. So I'll get 0.593 divided by, now the stoichiometric ratio of oxygen is 3. I'm going to divide this by 3, and this will give me the answer as 0.198. Getting the answer as 0.198. Okay. Now we have found out the K value for sulfur and oxygen. Now the rule says that whichever has a K value less, okay, or smaller, is the limiting reactant. So from this two values, you can see that 0.198 is less than 1.190. Therefore, we can say that limiting reactant is oxygen and not sulfur. So this is decided. So we got answer for the first part of the question. Like it was asked, what is the limiting reactant? So limiting reactant is oxygen, right? Fine. Now the second part of the question is, you will have to find out the amount of sulfur trioxide formed in grams. Now to find out this amount of sulfur trioxide formed, okay, you will have to take into consideration the limiting reactant, that is oxygen. Okay, because whatever sulfur trioxide will be formed, it will be dependent on the oxygen and not on the sulfur, because oxygen is limiting. It is going to be used up first, right? Sulfur is in excess. So oxygen is responsible for giving you sulfur trioxide. Once the oxygen is over, it is completed, then the reaction will stop. So all depends upon the oxygen, the amount of oxygen. So there's a method called fraction method, okay, in which we can start this way. Now, what is the starting uh, uh, information given to us about oxygen? It is given that 18.98 grams of oxygen is available to us in this reaction. Okay, so we'll have to take that. We'll have to start from here. Now, they have asked us to find out the uh, amount of sulfur trioxide in grams. So this is a question based on gram to gram. Okay, from 18.98 grams of oxygen, you will have to come to how many grams of sulfur trioxide will be formed. Okay, so I'm writing here grams of sulfur trioxide. Okay, this is what we want to find out. So this is basically known as gram to gram question or gram to gram conversion. In gram to gram conversion, you will have three factors. Okay, you will have three factors. Now let us see how to do this. Okay, now 18.98 gram of oxygen. First, I'm going to convert this gram of oxygen into mole of oxygen. So in the denominator, I'll write gram of oxygen because I want that to be cut out. Gram of oxygen should go away. And here I want mole of oxygen. Okay. Now, what is the relation between this gram of oxygen and mole of oxygen? So I know that 32 gram of oxygen is equal to 1 mole of oxygen. So I've written a 1 mole of oxygen upon 32 gram of oxygen. That was my first bracket. This first bracket will help me in converting the mass in grams of oxygen into mole of oxygen. Next is, now this mole of oxygen, from this mole of oxygen, I want mole of SO3. So from oxygen to SO3, the theory says that the ratio is 3:2. So I'll take 2 mole of SO3 on the top divided by 3 mole of oxygen in the denominator. Now, why I have taken 3 mole of oxygen in the denominator? Because I want this mole of oxygen from here and here to cut. Okay, that is the purpose, and that is why I took the ratio as 2/3 and not 3/2. So the second bracket will give me the answer for the mole of sulfur trioxide formed. Till the second bracket, I'll get the answer for how much mole of SO3 is formed. But the question is to find how much gram of SO3 is formed. So there will be one more conversion which will help us in converting this mole of SO3 into gram of SO3. So for that, again in the denominator, I will take mole of SO3. And I'm taking this mole of SO3 because I want mole of SO3 from this numerator to cut with this denominator. Okay. Now mole of SO3, 1 mole of SO3 is equivalent to how many gram of SO3? So S AR value is 32, O AR value is 16, and SO3 formula is for sulfur trioxide. So it will be 32 plus 16 times 3, that is 48, and this works out to 80 grams. So the molar mass of SO3 happens to be 80 grams. So 80 grams of SO3 is nothing but 1 mole of SO3. Now here, this in one go, okay, you'll get the answer. Okay, now let me cut out the things. This is gram of oxygen I am cutting. Mole of oxygen I am cutting. Mole of SO3 I am cutting. All this I have cut because one was in the numerator, the other in the denominator. So similar values in the denominator and numerator can be cancelled out. Now I am left with this particular calculation, that is 18.98 times 1/32 times 2/3 times 80.1, and this is grams of SO3. So this bracket quantity, if I reduce to a single number, that single number will give me the value for the grams of SO3 that is formed. Okay, so this is in one go how we have to do stoichiometric problems. Okay, now in my theory, I have explained everything in detail. In my theory sessions, I have explained everything in detail. This is just a revision session, so I'm just dealing with the current problem. And if this problem comes in the examination, this is the precise way you have to solve the problem. Okay, this is known as something called fraction method. Okay, so one should, by practice, you will come to know how these brackets, are to be filled up. Okay, so let us calculate this bracket value, and it is 18.98 times 2 times 80. This is all in the numerator, so this works out to 3036.8 divided by, in the denominator you have 32 times 3 times 1, that works out to 96, and this in turn works out to, let us see, 3036.8 31.8 divided by 96 is equal to 31.633. 31.633 is repeated. So this can be written as 31 point. Okay. 31.63 recurring. This can be written as 31.64 grams of SO3. So this is the answer to the third part of the question. I'm sorry, the second part of the question. That is, how many grams of SO3 is produced? And the answer is 31.64 grams of SO3 is produced. Now, this is the theoretical value of SO3 that you should get. Okay, 31.64 grams of SO3. This is the theoretical value of SO3 that you should get. Okay. Now, the last question is this one, percentage yield of sulfur trioxide. Now, the percentage yield is given by this formula, actual yield upon theoretical yield times 100. Now, what is the meaning of this? The actual yield means what actually you got in the experiment. So the experiment says that 30.12 gram of sulfur trioxide was formed in the laboratory. So in the laboratory means while performing the experiment, actually the sulfur trioxide formed was 30.21 gram. So this 30.21 gram is your actual yield. And the theoretical yield is just now that you calculated, that is 31.64 grams. This is the theoretical yield times 100. Now this, if you work out, this will give you the percentage yield. So 30.21 divided by 31.64 equal to, multiplied by 100, is giving me the answer as 95.48. Okay, 95.48. So if I want to go to 1 dp, it will be 95.5 percentage. So this is my answer for the percentage yield. So all the three questions I have solved for you. Okay, all the three questions in this particular question. So what is the limiting reagent? We came to know that limiting reagent is oxygen. Here we have shown you. And second was, what is the amount of sulfur trioxide formed in grams? And that we got as 31.64 grams. And the last question was, what is the percentage yield of sulfur trioxide? And that we got the answer as 95.5. Okay. So this is how you have to deal with stoichiometric numericals problems in your exam. Okay. That's all for today. See you in the next video with some more chemistry concepts. Till then, bye. Take care, all of you.